Welcome, everyone. Thank you for to be here. Today, I would like to talk about integration and end-to-end testing with test containers. Short information about me: right now I'm Go developer at Zalando in Helsinki, and originally I'm from Russia, from St. Petersburg. And before I served for many years as Java developer at Infobeep DevExperts. And a long time ago, I was C developer at Samsung and Motorola. So why integration testing matters? Here is the short video why it actually matters, why unit testing is never enough. So in this case, all integration unit tests would pass, but integration tests wouldn't, and it would fail in production probably. But we always have to keep in mind that with integration tests and end-to-end test, our test run time gets longer, and the amount of tests we have to write for integration end-to-end tests should be less. We should write more unit tests. But we can expand our scope of testing if we write integration tests and end-to-end tests. So what was the evolution of integration testing? So originally, it was in memory mocking probably. I remember I was doing integration test with H2 database, which was emulating Postgres database. Otherwise, you could start a local database. But that wasn't really CI friendly. Someone could use Vagrant, but when Docker came, you could use Docker. Also, you could start the Docker container locally. You could use Docker Compose, but still there are some disadvantages. And then you could use Docker API, and that gives us more flexibility. So if we want to use Docker, if you want to start some database in Docker, how can we actually do that? There are several options. We can run a shell script. It will start a Docker run. We can use Maven plugin. We can use Docker Compose, something else. And then these days, maybe we can do with Minikube or Kubernetes. And today I learned from previous presentation about test containers that there is kind, where you run Kubernetes for integration testing inside the Docker container. So if we go with shell script, then you don't have to go very much into details, but you could see that there are some issues already. There are too much code just to start the single container. The ports are fixed, so we expose to the host like the same port as in container, and it's fixed. We are not sure if actually Postgres started or not, so we have to sleep for 5 seconds, but maybe you got a CPU spike and 5 seconds wasn't enough, and then container wasn't ready and your test would fail. So, and that's not, and shell script is some language, it's not like the language you use for your daily work, like Java or Go, something else. So probably many people would avoid that. And then if you want to run a Docker, and I mean to run a Docker container, not to build a Docker container, then there is a Maven plugin. And a couple of years ago, I tried to use that one, but it was pretty much cumbersome to configure that in XML inside the Maven. So and then you could use Docker Compose to spin up several containers and run integration tests. But here there are also some problems. The ports are still fixed. So there could be some collision if you have some already existing service running at the same port. And what about cleanup in Docker Compose environment? Like after the test, you want your containers to be to be stopped, but out of the box, you cannot do that with Docker Compose. So to rescue comes test containers. Test containers originally is a Java library, and it became very popular. And what it does, it wraps Docker Java library, the one which uses Docker API, to start containers. And on top of that, it gives you some really nice features which simplify your life when you do integration testing. So you could do, it could do Docker environment discovery out of the box. You don't have to configure that. It does host port randomization, containers cleanup on shutdown of the test, and waiting strategies, and many more things. So if you want to start with test containers, it's pretty much simple. In the first line, you just start a Postgres container, and that one is called test containers module. So it's already knows that it's Postgres, and it gives you some already methods. So it's not a generic container, and it's easier to use. But in the second line, if the database doesn't exist as test containers model, you can always start a generic container and specify what image you want there, what version, and what port to expose to the host machine. So if you run test containers Java, then it would do Docker auto discovery. So in here you can see that it discovered the Docker. It's Docker for Mac, so you don't have to do that configuration for yourself. And then it does port randomization for you, so it prevents port conflicts at the host machine. It enables parallel builds, so you can run several test use. Both of them would start Postgres, Redis, and they would be exposed to different ports, the host machine, so there would be no clash. And there is API in Java to get that host, the random host port which was exposed. So in this example, there is that port 32,823, and Postgres was started, and inside the Docker container it has a fixed port, but outside at the host environment it's a random port. So there is also a feature which is very useful for integration testing as containers cleanup. So there is a special container which called Rike, and test containers start that automatically. And from the log you could see that Rike was started, and it would monitor the JVM, and once JVM with test dies, then Rike would kill all containers which were started by this JVM, and after all it would exit by itself. So you would have a clean environment after all. Then another useful feature is waiting strategies. For example, in the first line you start the user container for some user service, a generic container, and then you can actually wait. And in first case, we wait for maximum of 2 minutes, and we wait for some specific endpoint, health endpoint, to return status to 100. But in second case, we are just waiting for the host port to be exposed. But sometimes it's not enough. Maybe your web server has started, but still your application is not ready to serve requests yet. So in that case, you can customize that and do as in the first case. So okay, I have some demo prepared. So that would be a Java and Spring Boot environment. What about the font? Can you see that one? Oh. Yeah, I know. Now it's too big. Okay, so there is a very simple application for start. It's a Spring Boot application. What it only does, it has a user endpoint, and you can create a user, and you can get the user. So when you create a user, it's very simple object. It has ID, name, and email, and then I basically save it to Postgres, and then I return just ID of the newly created user. And then I get that one. I just read it from from Postgres by ID. So how would we test this one? So basically, this application is so simple that there is not much space for unit testing, but there is a space for integration testing because we use Postgres under the hood. So there is user controller test. So it's a basic Spring Boot test, and since we require Postgres in our application, there is a special integration of TestContainers library for JUnit5, and I use JUnit5. So there is annotation, TestContainers, and annotation container. And what it would do, if you specify both of them, it would start those containers before all the tests. And this keyword static here means that this container Postgres would be shared across all test cases. So I use that module, which is test container specific model for Postgres. So it's very easy to customize that with database name, username, and password. And under the hood, it has that. You can see it implements test containers somewhere under the hood, generic container. It has that specific Postgres image, some port, and so on. So I overrided here what I needed, and then I have to inject those custom JDBC URL and username and password inside my Spring Boot properties. So I override that with some initializer, which is indicated here, and then I can run the test. So let's run this test in debug mode. So you see test containers discovered the Docker, start in Postgres, and so on. So it didn't took much time actually to start that single container. So what we have now, so now in Docker PS we have that Postgres started and try container, which monitors this JVM to kill all started containers by this JVM. So then that Postgres is exposed at the random port, so I can actually connect to the database. I need just to customize the port. So yeah, so in my test I get some data inserted here. So yeah, my test is that I just create the user with a name Nikolay, and this is email. It's a fake email. Don't try to write me there. So then I just and then later I get it. I get this user, and the test should pass. So yeah, so this is the second case, second test. I create another user, and then I try to create a user which has the same same email. And because my initializing script to the database has that field unique, email field, then that test would fail, that creation of the user would fail, and it would throw Spring specific exception. So now I get this one new user was created, but another would fail, and I assert that it actually throws exception. So yeah, so now we have both tests pass, and now if I try to connect to the same database, Postgres, it's gone because it was killed by Rike. And if I see here in Docker PS, so all containers are cleaned up, and my machine doesn't have some zombie containers anymore. Okay, let's see another example. It's a little bit more complex application. Let's hide this one. Okay, so what I do here is there are two more endpoints to create some item and to get the item. And under the hood, I use Redis. And for Redis, I use latest driver, and those Redis commands are from Redis driver. And if I try to create an item, then each item has some ID, description, and category, and there is a user ID. And my logic is pretty simple. I want to check actually if that user ID exists in this system or not. And for users, there is a cache in Redis. So first I try to get that from Redis. If it doesn't exist in Redis, then I call the user service with Spring REST template. If it doesn't exist there, then I throw exception. But if it exists, then I store the user to Redis. And then I actually store the item, and I store it in memory. And this is item store is concurrent hash map. This is just to simplify the application. So yeah, so our application here has a dependency. It depends on Redis. And if you want to test this one, so yeah, so in this test, so yeah, it's the same Spring Boot test, and it uses the JUnit5 annotation from TestContainers. Then I annotate this Redis container. I use the latest version and expose the port. And what I do in the test, I create the user, and then I have actually, because under the hood, the item service calls user service to verify if that user exists or not. I need to mock that one, and I do it by Spring. This part is mocks a JDBC template. Then you try to get some user. It would always it would return. Yes, it would return Nikolay and this email. So yeah, let's see how this test works. So yes, I started the test. Now we have that Redis running, and we have Rike again. And then we would just create the item, and then we would get the item, and that should be something what we expect. Okay, the test pass. So what if I remove that Redis? So to verify that it actually depends, this test would fail because I'm not using Redis anymore. So yeah, this test fails because Redis was gone. So yeah, that was a simple demo. But now let's think, why would we need end-to-end testing? So we just saw about integration testing. What about end-to-end testing? So end-to-end testing would require some more time, runtime, because like we have to start several services, their dependencies, and so on. But sometimes it could be useful if you have some critical services, and then actually the flows of the data which brings money to your company, they're not only about one service, but maybe just several services, or you could identify those services which are crucial and have end-to-end tests for those services. Then in this case, test containers could be suitable for you as well. And another use case was, which I was doing, is that, for example, you want to replace some legacy service and provide a new implementation. And in that case, if you have existing end-to-end test, then you can easily verify that, okay, this is equivalent replacement of the legacy service and nothing would break in production. So yeah, this is the end-to-end setup I would like to consider. So we just saw there is a user service which holds the users, and there is item service, and it calls the user service and to check whether the user exists or not. And user service uses Postgres, and item service uses Redis as the cache. And then in this setup, we are not using Kubernetes, but we are using Spring Cloud environment, and we use discovery service which is called Eureka, and Eureka is the service registry where each service has to register at startup, and then after all it would get the data of another services which exist there, so they could discover each other. Then you perform, for example, a call from item service for user service. So this is example for Eureka, and in our case we have item service and user service registered in that Eureka. So let's see another demo how we could do end-to-end test with the help of test containers. So this kind of So let's see here. These annotations, they are custom annotations from JUnit5, which I implemented. And that's kind of, we hide all the container startup and under those annotations. So for example, how it would work. For example, for user service, there is a mechanism in JUnit5 that's called JUnit5 extension, and it would basically just start our user service container, then the test starts, and it would stop, then the test stops. And in here, we basically hide all the configuration and setup. So the thing that if we want to use that end-to-end test, we have to provide the same network, same test containers Docker network. So all containers would share the same network. So it's very easy. So yeah, we just reuse that network. We have here that host port waiting strategy. And yeah, we set up that, so for each service, we specify some alias in that network. And then we specify how to find, for example, Postgres, what would be address of the Postgres, what would be address of Eureka discovery service, and so on. So let's try to run the test So the test is pretty simple. We create the user, we create the item with the same user ID, and then we would get that item, and everything should work, even though we do some validation and so on. And in the test, we would start Eureka user service, item service, and their dependencies as Postgres and Redis. And that one would take actually quite some time. It would take about 1 minute. So during the waiting time, we can consider what our alternatives to end-to-end testing. Okay, so there are many practices we could do, but the goal is to minimize changing of break-in production once we deploy. So of course we can use a staging environment, but sometimes it gets a little difficult. Then like different teams deploy a different experimental version, and if you depend on their service, then you don't know why your service at staging doesn't work. If it's because you broke something or because someone else deployed some unstable version. Okay, now everything is started. In our test, as I said, it took quite some time, about a minute, and we can see that we have all those containers being started with Redis, Postgres, and our custom services, user service, item service, Eureka. And then if I run actually the test, so yeah, test has passed. So yeah, back to alternatives. So we could do canary deployment also. In that case, we don't risk to break all production, but just some fraction of production traffic. And we could do the contract testing. There is Spring Cloud contract, for example, if you use Spring ecosystem. So yeah, and there are some hints from my side for extensive usage of test containers. That's sometimes you need to export port from inside the from your host environment inside the container network. And for that case, it's very easy. There is just a single method in test containers, and that actually saved me at some point. And then sometimes you want to do remote debug of your Java application inside the container. And for that purpose, it's more convenient to have a fixed exposed host port. Though it's not recommended to do that, you could still do that for remote debug. And at some point, I had a code which actually detects if I run in at Jenkins, then it would not use the exposed remote debug port. But if I'm running for IDE, then it would expose that fixed remote debug port. So it's easy for me to connect there. And if you need, you could disable Rike, so your containers wouldn't be killed after the end of the test. So test containers comes with a lot of handy modules. It's more than 10 databases. So in there, for example, for Postgres, it was that Postgres containers already knows that there is a user, there is a password, there is JDBC URL. So you don't have to do that from scratch. You can do HTTP mocking with mock server model, and you can emulate AWS services with a local stack, which I haven't tried myself. There is a toxic-proxy model where you can emulate network failures and to see how your test and application would behave if, for example, it cannot connect to Postgres or Redis like 50% of the time. There is model for Kafka. So if you have not tried test containers yet, that's a good opportunity to try because it's provide really great benefits like flexibility, speed, and a lot of features. Of course, you would your test, if it's integration test or even end-to-end test, it would take a longer time. But so in that case, development would be longer, but you would feel a bit more safer if you have those tests before you deploy some crucial service to production. So it works across different OS. And thank you. You can reach me. You can reach me out by Twitter. And those examples you can find at GitHub, this account, and you can experiment. Thank you. Any questions?
You had the annotations for JUnit5. Is it also possible to use it with JUnit4?
Yes, of course, it's possible to use test containers with JUnit4 and many other testing frameworks. But those annotations, they're just a little bit more concise and a little bit more magic. But yeah, it doesn't restrict you to JUnit5.
Okay, cool. Thanks.
Okay, thank you.